In today's video, we'll be synthesizing ferrofluid. Ferrofluid is a magnetic liquid that is made by suspending magnetite nanoparticles in some sort of liquid. In theory, this should be very simple, but in practice, it definitely wasn't. To get started, I pulled up a lab manual from the chemistry department. This would be a good starting point because I really didn't know where to begin at this point. To get started making my ferrofluid, first I would need to actually get the supplies. So, I just had to obtain some iron 2 chloride as well as some iron 3 chloride. This only required a fast trip to the chemistry stockroom, and once I got them, I just simply added 2 milliliters of 2 molar iron 2 chloride to 8 milliliters of 1 molar iron 3 chloride. After I finished adding the FeCl3+, next I just had to throw in a stir bar and begin stirring the mixture. Then I slowly started adding dilute ammonia, as was called for in the procedure, to our mixture. It was really important to do this slowly and over the course of a good amount of time to ensure that the magnetite particles being formed were nice and small. In this clip here, I sped the video up quite a bit just for time's sake, but I think that the sped up video is really cool because it shows the color change of the solution more drastically. The reason that the solution is getting darker is because magnetite particles are starting to form. As more of the ammonia goes in, more magnetite gets formed, and the solution just gets darker and darker until eventually we're left with a very inky black mixture. Once all of the ammonia was finally added, I decided to take the mixture off the hot plate and put a magnet under it to help settle the particles to the bottom faster. The black clump at the bottom is all magnetite, and hopefully it's good quality. Next, I just decanted off the rest of the liquid and saved all my particles for the next part of the procedure. Next, I had to somehow get the magnetite particles out of the beaker, and this was actually extremely challenging. I tried for a few minutes to do this, and I didn't really show all of it, but eventually I did manage to get a good amount of the particles out. I think that it was a good thing that it was so clumped like this because it made me think that the particles were probably pretty small. Once I had gotten all my magnetite particles into the weigh boat, I filled up the weigh boat with a little bit of DI water and then put a magnet under it just to collect all my particles and give them a good wash in the water. After I did this, I just took the water out and then simply added tetramethyl ammonium hydroxide. This would be a good base that would be able to stabilize our nanotite particles so that we could actually get our colloidal suspension, which would pretty much just be our ferrofluid. I then started stirring very vigorously, and this was really important to ensure that we got a good even mixture of our ferrofluid. I mixed it for a while, but I didn't include all of it because I didn't think it would be necessary for you guys to see. I mixed for a while, but once I was done, I was really excited and nervous to test. So I simply put a neodymium magnet under it and immediately got a huge blob, just like you see right now. I decanted off the excess liquid from this big blob, and I was pretty upset at first because it didn't spike, but then when I held the magnet just a little bit further away, suddenly I got some very nice spikes. These spikes looked quite good to me, but I thought that I could do better. I went on the internet and went to YouTube and found a video by Nile Red where he makes an oil-based ferrofluid, and I just wanted to try it for myself. So this next part of the video is an adapted version of his procedure. Even though this ferrofluid was alright, I just thought that we could do better. I didn't get very much of it, and it stuck to the walls like crazy. The instant that it touched any glass walls, it took a long time for the ferrofluid to drain off of them. The next day, I got to work. I threw in a stir bar and some water into a beaker and then added my FeCl2 and FeCl3. This time I was mixing the mixture much faster with the stir rod, which was allowing for magnetite particles, once they were formed, to be immediately dispersed to try to keep large clumps of magnetite particles from forming. I then set up a separatory funnel filled with concentrated ammonia. I did use a separatory funnel just because this was the only glassware that I had that could add the ammonia in dropwise. I did this over the course of about 20 minutes and added a good amount of ammonia. This time, however, I used pH paper to be checking when my reaction would be complete instead of just knowing a set amount. So as you can see, the solution here was turning darker and darker. This was because the magnetite particles were forming and being stirred around in the solution. You can actually see the particles form and then disperse in the video. The little black dots there, that's the magnetite. One of my concerns was that because I was using a magnetic stir bar, magnetite particles would obviously be attracted to it, and it did end up being okay. I did lose a bit of my yield because of this, but it didn't really matter because I wasn't really trying to get the maximum amount of magnetite from this. Once I was about convinced that the reaction had finished, I just let it stir for a little bit longer and then checked the pH 2 or 3 more times to make sure it was okay. And then I stopped the addition of ammonia and took everything apart for the next part. This next part of the procedure was the most important for making this a different ferrofluid. I needed to make a detergent called ammonium oleate by adding oleic acid to some ammonia. And when I looked in the stockroom, I could only find 0.5% oleic acid. And because of this, I was really concerned that my magnetite particles wouldn't actually get coated by the detergent and this would not end up working. But I decided I'd go ahead and try it anyway. So after I had made it, I added my small amount of very dilute ammonium oleate to the mixture while it was still mixing, and then I just let it mix for around 10 to 20 minutes, and I checked the pH again just to make sure that it was all still good. Once I was convinced that I had mixed enough, I turned off the mixer and I held the neodymium magnet to the side of the beaker, and instantly I could feel a very strong pull from the magnetite particles, which meant that I had at least made magnetite. This I thought was a really pretty shot of the magnetite, of some of the weaker magnetite particles floating around, and I just thought I'd throw this in. But at the bottom, you actually can see a good amount of magnetite at the bottom, which this made me very excited. This was a good amount of magnetite, I thought, and I was excited to try to make the fluid, but I was also still nervous because my ammonium oleate was not very good. While looking at this really nice video here, I decided that it would be a good time to talk about what the ammonium oleate was supposed to do. The ammonium oleate is a detergent, and the head groups of this detergent are supposed to be attracted to the charged magnetite particles and form a barrier around each individual nanoparticle. This is actually really similar to how soap works, in that when soap is getting the dirt off your hands, it's being a surfactant, which means that it's actually adhering to the nanotype particles and making it so they can't stick to things or each other, which is why detergents work so well at cleaning things. The only difference here is that I was trying to do this on magnetite. Once I had felt that the magnetite had settled enough to the bottom, I decanted the rest of the liquid off, and I wasn't too worried about all the magnetite you see floating around being lost because it wasn't attracted to the magnet strong enough, so I was fine with losing this lower quality magnetite. Once I decanted all of the extra liquid out, I decided to give it a wash with isopropyl alcohol, just like in the Nile Red video. This was good for getting some of the magnetite off the walls and kind of getting it into a more workable form so that I could pour it into something else so that it wouldn't be getting super duper stuck. Once I had given my magnetite a good wash, I decided to add it to a vacuum filter. I did this because I wanted to actually get just the magnetite powder this time before I tried to suspend it. I had underestimated just how fine these particles were, and I added way too much to this small vacuum filter, so it took a crazy long time to filter through, and this was only one batch. So what I had to end up doing was setting up a second bigger vacuum filter and putting the rest in there. It took a good amount of time, but once my magnetite had finally dried to a nice powder, like you can see here, I wanted to weigh how much I had, and I was actually quite proud at this point of how my magnetite was looking. I threw my magnetite onto a scale and found that I had just about 3.5 grams. I then took my magnetite particles, and this was the moment of truth. I added kerosene to try to suspend my particles, and I mixed, but it looked like my worst fears had come true. It looked as if the small amount of poor quality ammonium oleate that I had made was not enough to coat all my nanoparticles, and what I had here was just an oily mess of magnetite. At this point, I started freaking out a little bit, but then I realized that I could probably just wash this with some tetramethyl ammonium hydroxide to separate out the kerosene while simultaneously suspending my magnetite particles. So I hadn't given up hope completely. I started trying to gather all the magnetite particles in the middle of the dish so that way I could get rid of as much of the kerosene as possible before adding the tetramethyl ammonium hydroxide. But once I did, it instantly started to dissolve the magnetite particles into it while the kerosene started floating on top. At this point, I could breathe again, and I was pretty relieved because it seemed like as long as I just kept washing it with tetramethyl ammonium hydroxide, I would be able to save this and at least make some ferrofluid instead of all my hard work going to waste. So I kept washing and washing until eventually I was satisfied that most of the kerosene had gone away. I put a magnet underneath to gather my fluid, and this seemed to be a good mixing technique because it allowed for all the magnetite to be in the center while I mixed it so that all of the kerosene, as you can see, could be pushed out while my base, tetramethyl ammonium hydroxide, was dissolving in. I kept washing, and at this point it probably wasn't necessary, but I really did want to try to get as much kerosene out of there as possible. Even though I'd be able to salvage these magnetite particles and make some ferrofluid, I was still really disappointed that I wouldn't be able to make the oil-based ferrofluid. But this time I got even bigger spikes than the first time because I think just some of the other parts of the technique were better, and I don't know, this cheered me up a little bit, but in the back of my head I knew that I was going to have to try again. At this point, though, I was really tired of ferrofluids because I had been working on it for a while, but I just couldn't let it go. So I knew that the first step would be obtaining some higher quality and much higher concentration oleic acid. I decided to try making the oil-based ferrofluid again. I won't show the clips before the making of this oleic acid because all of those steps are essentially exactly the same. So, when I added my oleic acid with some water and ammonia, I instantly got this nice thick white detergent, and this was a lot better than what I had gotten before with the less concentrated and much smaller amount of oleic acid. I mixed it around for a bit, and then once it was nice and mixed, I decided to throw it into the mixing mixture of the magnetite. Once I had thrown it in and mixed it, I just let it mix for a while because I didn't want to take any chances with my magnetite particles not being covered by this oleic acid. Once again, the oleic acid is acting as a surfactant, which means that it's coating the magnetite particles and keeping them from sticking to each other. Because the ammonium oleate was being a surfactant and attaching to the magnetite particles, this is what was going to allow this ferrofluid to be oil-based, because I had a non-polar substance covering my nanotype particles, which means that I should be able to suspend my non-polar coated magnetite particles in a non-polar liquid. And once again, I'm going to use kerosene just like I did when I tried the first time, and I was quite nervous. Once I had allowed the ammonium oleate to mix for long enough, I then decanted my mixture, and I was left with a lot less magnetite at the bottom than last time. And I think this could have to do with the ammonium oleate coating that was on the magnetite particles. I believe that for the particles to stick to the magnet, they had to be extra magnetic, and the ammonium oleate was making sure that I was only getting the highest quality magnetite, but that is just a guess. I could be wrong. This time, I used a much bigger vacuum filter right off the bat to vacuum our nanotype particles, and it worked a lot faster, thankfully. However, I did still do it in 2 batches just to be safe, but this is real time, and you can see it went a lot faster. Once my particles were fully dry, I took my spatula and kind of scraped them off the plate and kind of got them all in the center, and I was quite happy because this magnetite was super fine and powdery, and I thought that it had a great chance of working, but I was super nervous. Once it was finally time to see if this would work, I slowly added just a little bit of kerosene. I added a little bit more, and then if you look carefully, you can see that it actually did start dissolving. I started mixing, and I was so happy at this point because I could tell that it had worked. I had actually made an oil-based ferrofluid, and it only took 2 tries. I mixed this for a fairly long time because I wanted to make sure that I had the best possible ferrofluid I could from this pretty small batch. Once I was done mixing, I took my magnet, and it was weird. My ferrofluid looked kind of grainy, which I'm not sure why that is, but it was spiking like a ferrofluid should. Maybe it just needed a little bit more time for all the magnetite particles to get dissolved, but nevertheless, I was quite happy. I then took this and added it to a little vial filled with water, and it seemed to be acting a lot better. It wasn't grainy anymore, and I had finally managed to make that nice vial with magnetite in it without the magnetite coating the walls. I was so happy because this had taken like a month to do while being a full-time student, and this meant that all I had to do now was get some nice shots of it and then do the voiceover, which I'm doing right now, which is actually turning out to be one of the harder parts of this project. I set up this cool little experiment that I saw other people do on the internet. However, I didn't really have a nice big screw, so I just used this little one, but I still got these really nice spikes forming. I'm really excited for the future of this YouTube channel, and I'm looking forward to doing many cool chemistry videos in the future. This couldn't have been done without my friend Aaron, who helped me film everything and really cut the time in half from what it would have taken otherwise. I also want to thank the New Mexico Tech Chemistry Department for giving us a good laboratory to do these experiments in, as well as providing us with plenty of chemicals and equipment. Chemicals are not cheap. I used a little vial of oleic acid, and it was reagent grade, which might not have been necessary, but that little bottle was $250. So I just wanted to mention that because I really want to emphasize that this wouldn't be possible without the support of the New Mexico Tech Chemistry Department. I then thought that as a final cool shot, I could put all the ferrofluids that I had made next to each other. As you can see, the nice oil-based one wasn't sticking to the walls like the other ones that were suspended in tetramethylammonium hydroxide. But I'm really tired of ferrofluid, and I'm really not going to do it anytime soon again. Maybe I'll revisit it in like a year. I don't know. Anyway, thank you so much for watching this video. I'd really appreciate if you guys subscribe and let me know what you guys think. And thank you so much for watching. I can't wait for our next video.